we're doing probability. We're going to do something cool. We're going to combine something we learned before, Venn diagrams, and calculate some probabilities with that. Which is kind of cool. Imagine we have a survey. 100 people were asked whether they like coffee or tea. And this diagram shows what their answers were. So remember, the people that like coffee are inside this circle, so these 13 and these 46. The people that like tea are in this circle, so these 25 and these 46 together like tea. This group in the middle here, these 46, they are both in the tea category and in the coffee category. So they like both coffee and tea. So there's 13 people that like coffee and really don't like tea. There's 25 tea drinkers that don't drink coffee. And there's 46 people that drink both. These 16 out here, do you remember what they were? Why are they outside of all the circles, but still inside the box? Well, they were inside the survey, so they were asked the question, but they liked neither coffee nor tea. So these are the 16 people that said, ugh, I don't like either. Right? They're over there. Okay, that was Venn diagrams. Now, imagine we're picking a person out of these 100 people at random. Right. Find the probability, P, that this person does not like coffee. No coffee. So find the probability of the randomly chosen person from all 100 people. What is the chance that they don't like coffee? Okay. We need to know how many people we're choosing out of, and we know that that's 100. So the total is 100. The number of people that don't like coffee are just really anyone outside of this C circle, right? So these 25 and these 16 that don't like either, right? So the 25 that only like tea and the 16 that don't like either, those together is 41 people, and we said the total number of people that we're picking our person out of randomly is 100. So the probability that randomly chosen person does not like coffee is 41 out of 100. Okay? That's an easy one. Say we only look at people that like coffee, right? And out of the people that, I'm saying coffee and pointing at tea, say we're picking a person randomly out of the group of tea drinkers. So this group, the tea drinkers, we're picking one person out randomly. What is the probability that this tea drinker also likes coffee? The probability of that happening is also likes coffee. So these 46 people are inside this tea drinkers bubble, and they also like coffee. So 46 people also like coffee. We're picking them out of the group of tea drinkers, which is a total of how many people? 46 plus 25. So 71. Right? The probability that we pick a tea drinker that also likes coffee is 46 out of 71. 46 out of 71. That's the probability. Okay. Now, our third situation. What if we pick 2 people out of the whole group at random? What is the probability that they both like coffee? Okay, how about we figure that out for the first one we pick out? We pick 2 people, right? We pick one first and then we pick another one. What is the chances that the first person we pick likes coffee, and then when we pick a second one out, that person also likes coffee? Well, let's figure out the first person. The first person we pick out is a coffee lover if they are inside this bubble. So we have a total of 59 coffee drinkers, right? These 13 people that only drink coffee, the 46 that drink coffee and tea. Added together, that's 59 people, and we're picking them out of a total of 100 people, right? So that is the probability that the first person we pick likes coffee. What is the probability that the second person we pick also likes coffee? How many people do we have left if we've already picked one out? We don't have under 100 people to choose from anymore. We have 99. So we know that it's going to be out of 99. How many coffee drinkers are left after we've picked out our first one? Well, we've already picked out one and set him aside, right? Okay, we've got our coffee drinker. Then when we pick our second person, that person's no longer there. That's why there's a total of 99 instead of 100. And also the total number of coffee drinkers has gone down from 59 to 58. So now we have a chance of 58 people out of 99 people, right? So the probability that the first person we pick is a coffee drinker is 59 out of 100. The probability that the second person we pick out after that also drinks coffee is 58 out of 99. Now, what is the probability that both 1 and 2 happen? So let's say this, 1 and 2 are both coffee drinkers. It is the first probability multiplied by the second probability. Remember how in the probability, when we drew those branches, we would multiply across the branches? That's what we're doing now. The chances of the first thing happening times the chances of the second thing happening determines the chances that both happen in a row. 59 times 58 is 1711. 100 times 99. No, this is simplified. Sorry. Right. Yeah, I'm not gonna do this out loud. I'm just copying it down for my answer here. And these are big numbers, so if I want to plug that into my calculator and show it as a decimal, that gives me a better idea. 3, 4, 6. So this is like almost 35%, right? 35% chance that the 2 people I pick both drink coffee. That sounds about right. Okay. See how fun it is to do 2 things that we learned separately, to do them together. I think it's pretty cool. Well, I hope you enjoy it.